nature-like technologies at human disposal.
Hello, this is Emerald Company, and we would like to make a brief video of connection startup of AQUACHLOR system. Let's briefly go through main parts of this machine. So in the upper part there is a power supply, you can see it there. This is a LED display which is in charge of operation. Let's open our body case and see inside. So this is the PCB made by Emerald. Power supply for electronic components, fittings, all with each number so that it can easily be connected, disconnected, so on. Here we see the dosing pump, which doses the working brine solution, sodium chloride solution. It is a flow meter to refill cathode chamber. This is the pressure regulator to monitor pressure in the anode chamber. And this is the main pressure regulator. This is the safety pressure regulator. This is the catalytic tank where caustic soda solution is circulated. We see the line of hydrogen separation there. And this is another line of hydrogen separation, which separate hydrogen from the catalyst. So from this tank, there is a line where catalyst goes out, caustic soda solution. It can be accumulated in the tank for future usage. So here the catalyst goes down and the hydrogen goes up. So this is the hydrogen outlet. It is a signal lamp. We will see how it works a bit after. This is our core electrochemical models where electrolysis is happening. This is anode line. We will cover it later. Here we connect chlorine sensor from the pool, for example, which can send signals for device on and off. This is again the power supply. And let's describe the main connections here. So from left to the right. So this is the outlet of caustic soda solution. This fitting is used for service only to drain caustic chamber and anode chamber. The white fitting is for reverse osmosis water supply to replenish cathode chamber. This is the dosage of brine solution, sodium chloride, and this is the dosage of water, tap water. So again, from right to left now. Here we put the tap water, which is used for cooling and mixing of oxidants with water. Here oxidants goes out and we mix them with water. And this solution of oxidants, it goes to the swimming pool or to water which needs to be disinfected. So tap water, brine solution inlet, reverse osmosis inlet, service fitting for drain. When we need to drain something, we connect a tube here. And the outlet of caustic soda solution. And the main one, outlet of oxidants. Here we have two walls just for our usage, because we can, by the second wall, we can take out a sample of the solution which is going out to check it for active chlorine level concentration. And the main electrochemical cells. This valve is served only for service when we need to drain anode chamber. In the working mode, it is closed. And here also we see the valves, they are all should be closed. They are also for services. So for example, this one, it is opened only for the first startup of the device when we need to quickly fill the whole tank with catalyst. And these three valves, they are used for drain. So this is this valve to drain anode chamber and this valve to drain cathode chamber. Okay, so we move forward and we will now describe the core functions and the hydraulic scheme showed in the display. So these buttons, start and stop, are similar to these buttons. And we have three main regimes: auto, service, and hand. Auto regime, here machine works in fully automatic mode, but according to the external signal. In our case, it is just a button connected here or to sensor, but in real practice, it is connected to the chlorine level sensor, for example, in the swimming pool, which shows the signal to start the machine on or off, according to the chlorine level sensor in water. So the second regime, it is service. Here machine also works in automatic mode, but without any external signals, just two buttons, start and stop. And hand regime, we need to add to enter user password here to be able to work here. Here we can turn on and off each part of the machine separately. It is used for service or for the first startup. And let me briefly describe the core hydraulic logic. This line is supply of tap cold water. It is supplied to the machine. Here is a flow level sensor. It passes through cooling parts, chilling parts of cathode chamber, cooling the catalyst inside the cathode chamber. Then it goes to the anode chamber, cooling anodes of electrochemical block. And then oxidants are injected here to this water and go out. So water serves for two main reasons. The first, it cools electrochemical block, cathode and anode. And second, it dissolves gases oxidants to transport further to the swimming pool, water circulation line, or to water treatment station supply line. Second, brine solution. Brine, it is concentrated sodium chloride solution, like 26 or 28% or higher. It is dosed by the dosing pump, this one. It is dosed to the anode chamber, where synthesis of gaseous oxidants is happening. And these gaseous oxidants are injected to the water by special titanium pressure regulator. You can see them here. This is two pressure regulators, the main one and the safety second pressure regulator. So the oxidants are synthesized, they get here and they get out here to be injected in the water which flows here and go out. Third line, it is for service. It is the salvage of catalytic chamber and anode chamber. These ball valves are used just for the drain. So you see them here. This is the drain of the anode chamber. This is drain of the cathode chamber. To drain it, you need to open. In working mode, all ball valves should be closed. And this valve is to replenish cathode chamber with reverse osmosis water, here or here. It is this ball valve in working mode should also be closed. It is used only for first startup. So the logic of catalytic chamber is the following. We have a catalyst inside this tank, this one, and we have a circulating pump which circulates this caustic soda solution through cathode chamber, just circulation. This pump, the green one. So it takes caustic from the tank and put it to electrochemical blocks to cathode chamber, circulation. In cathode chamber, we have a synthesis of hydrogen. So that is why we have two outlet lines of hydrogen, which I showed at the beginning. The first line of hydrogen and the second line, where catalyst goes out and the hydrogen is separated. To replenish cathode chamber, we use reverse osmosis water, which is dosed through a special flow valve. This one. This flow valve enables to regulate water flow at a very small rate, like 10 milliliters per minute or 80 milliliters per minute. For this machine, we install from 10 to 20. So reverse osmosis water is dosed at a slow rate to the catalytic tank, and that is why we have always an overflow of some part of catalyst to the drain. So this is the core idea of the hydraulic scheme. So now the most interesting part of this video, the startup of this device. We have already made the first startup procedures, filling the catalytic tank with water. So you see the level here. That is why it shows in green that the level of catalyst is okay. So we are in auto mode. We put start button, but the system says waiting, unit status is waiting. It means that it waits for signal from external chlorine level sensor. In our case, as I showed, it is just a button which is used to show this signal. So I press the button and the unit status is changed to working. The startup goes in the following regime. The first is pump circulation. Cathode chamber pump circulation is on. You see it here, the green one. Then water flow is on and the dosing brine pump is on to replenish the level in the anode chamber. You see it here. You see the level of brine in the anode chamber gets up to the necessary level. So the system says the brine level is okay. Dosing pump is on, is off, and only now power supply turns on and the solenoid valve to put reverse osmosis water to the cathode chamber is on. So this is the logic of the startup of the machine. That is all. So now the system works fully automatically. You see 200 amps and 4.8 volts, which is a very good regime. So the pressure in the anode chamber is 1.6 bar according to electronic pressure sensor. And you can also double check the pressure in the anode chamber by the manual pressure gauge. And you see the synthesis rate of oxidants, which is around 260 grams per hour. In this regime, the system will work automatically, just maintaining the proper salt level in the anode chamber. So this dosing pump, this one, it will turn on and off to maintain the proper level of the brine solution. So the brine level during the electrolysis, it is now going down slowly. It will go down approximately here, and then the pump will dose it back. So that is all. And the synthesis of oxidants is taking place. When the system of the swimming pool or water treatment see that the chlorine level is enough, the signal is broken. So now the system is waiting status and it goes through stop procedure. Power supply and reverse osmosis supply is off instantly. The caustic pump will be turned off in around 30 seconds. And the water supply will also be turned on in 30 seconds. That is all. The machine is off in waiting status. Again, we have a signal to start and the similar procedure. First, caustic pump is on, then the brine pump is on to refill the level, and water supply is on. You can see here the flow rate, like 5, it will be around 680, something like this. The brine level is okay, and only after it power supply is on, simultaneously with reverse osmosis supply. In this regime, the machine can work automatically. Again, stop, and the system will pass through the stop procedure as described before. Caustic pump and water supply are turned off in 30 seconds. Power supply and reverse osmosis supply are turned off instantly. Okay, so the most interesting part of the video, let's get back again to the working mode. Send signal, waiting for 30 seconds, and we will now see the real electrolysis process here. So you see, when the power supply is off, nothing happens. So the tubes are just standing without any process. Nothing interesting here. Water is on, we have pressure. The brine level is pumped up, so it is okay now. And the power supply is on. Let's see the startup of the synthesis process. So you can see the oxidants starting to synthesize. The interesting thing that the inlet tubes, this is the inlet to cathode chamber, this is inlet to anode chamber, they are just with liquid. Here caustic soda circulates, here brine solution circulates. But the outlet tubes, you can see they're full with gases. Here it is caustic with hydrogen, which is then separated, and here it is brine solution, which is not converted and will go back with gaseous oxidants. Here are these oxidants go into the separator. So the core idea of this separator is that the brine, which is not converted, it goes back to electrolysis, and gaseous oxidants, they are separated here and goes to pressure regulator to be injected in the water flow and out of the device. Let's look from this side. Outlet of caustic with hydrogen, outlet of oxidants with brine solution. A few things here. In this question button, there is a core information about the system. Name, manufacturer, core product specification, serial number, manufacturer and date. Here, the first display shows the core settings which may be needed for the user. So the main one, in fact, is the current reference. So if you want to increase, for example, the current, which is possible here, let's say it will be 220. You see the system very fastly goes to 220 amps and stabilize this current level. So now you see, for example, 220 amps, and the synthesis of oxidants is 285 grams per hour. And the pressure in the anode chamber is 164 bars. So we put it back. You see, the system stabilized 200 amps. About the user password, for example, if you need to enter to go to hand mode, you just enter 1111, enter, and the user password will be there. In some cases, it may be needed to go to advanced settings. For example, you can change the time of the pump to circulate caustic soda. It is not needed, but just as an example, you put like 40 seconds. Enter, 40 seconds. If you need to save parameters in the long memory, you need to push save parameter. If we have a user password entered, we can go to hand mode. In hand mode, each element can be operated manually. So we put the start button, see the working unit and the lamp. Here we can do what is needed for the surveys or for the first startup of the machine. So for example, we can turn on the water supply, and you see the water flow rate goes up. We can turn it on by pressing again. We can turn on the brine dosing pump, this one. Turn off. We can turn the caustic circulating pump, the green one. It can only be turned on if there is enough level of caustic in the cathode chamber. It cannot be run dry. So we have a brine level, we have the caustic level, we can open the water flow, we can open reverse osmosis flow and start the power supply. In this regime, the machine will not work automatically and will not keep the proper level of the brine solution in the anode chamber because it is fully operated by the person. Turn off. So I think the idea is clear. And what is important is that we have a chlorine gas concentration sensor in the air. You see these values here. It is very important for safety issues. This is the sensor. It measures the chlorine in the air, and in case some leakage in the device, it will immediately turn it on and say that there is an error. Let me show it. For example, I will take a paper which is in chlorine and put it close to the sensor. See, the level goes up. It will reach the maximum, which is 350, and the system is turned off and says that there is an error. Maximum chloride concentration in the air. And the light is turned red. I have removed this paper and the chlorine gas concentration says 0. So we can, in this case, we can eliminate this fault by pressing stop. All faults can be eliminated by pressing stop if they are non-constant fault. Thank you. Bye-bye.
Emerald, nature-like technologies at human disposal.